All right, so let's finish up yesterday. We had piecewise. So we're going to finish up piecewise. We did the step functions. Steps look like what? Like steps. I sent you the answer for yesterday's letter B. Good? Did it make sense? All right. Do you understand why we had infinity and negative infinity? What made us have negative infinity and infinity? Anyone want to take a guess? Because it had a what at the end? Had an arrow. So that means it kept what? Kept going. Okay? So since it kept going, there is our answer. All right. All right, so that was example letter C. All right, we're going to graph negative 5, comma 3. God bless you. Negative 3, 0. 0, 4. And 3, negative 4. So negative 5, comma 3. Negative 3, 0. 0, 4. And 3, negative 4. Way to connect. All right, looking at our function here. It's this piecewise function because it looks like pieces of a graph. This looks like a what kind of graph? Which one? Absolute value. But then doesn't this look like a absolute value also? So it's kind of like we put two pieces of an absolute value kind of together. It's kind of what it looks like. So it just looks like two pieces or multiple, multiple pieces put together. So the first thing you're going to do is identify intercepts. So your directions are a little bit different. We're going to identify intercepts. The second thing we're going to do is identify increase, decrease. Identify positive, negative. And locate relative maximum or minimum. So we're going to identify the intercepts. We're going to identify increase and decrease, identify positive and negative, and locate the relative max or min. Yeah? All right. If I'm looking for intercepts, what kind of intercepts am I looking for? X-intercepts first? Sure, why not? How many x-intercepts do you see? 1 and 2. What are those points? Negative 3, 0, and 2, 0. Good. What's next? Y-intercepts. How many y-intercepts do you see? Just one. What is it? 0, 4. Good. All right, I want you to identify by yourself. I'll go back over it in a second, but I want you to identify your increase and decrease. So maybe if you just want to write it on your graph right now, you're still a little stuck, but increase and decrease. So I want you to identify increase and decrease on your graph. Maybe you want to highlight. Maybe you just want to label it. Okay. Increase and decrease. All right, when I look at my graph, from here to here, is that increase or decrease? Decrease, good. From here to here, increase. Here to here, decrease, good. All right, so when I label my increasing interval, I'm going from where to where? What number is this? -3, comma, 0. Very good. Remember, it's in terms of x. Nice. All right, decreasing. I have the first one here. So where am I starting? -5, 2. Negative where? -3. Then I start back again at, and I go to +3. Good. Remember? Why is it not infinity? There's no arrows. Good. All right, go do positive, negative. That's where I like to highlight, positive, negative. What does it mean to be positive? Say it again? No, not where. What does it mean? Above the x-axis. So this is above. And this isn't technically above, but here, yeah? And then this is below. Yes? Okay. So where are we positive from where to where? -5 to 2. Or you could write -5 to, what's this number? -3, and then again from -3 to 2. Okay? Just so you know, either one of those is fair because it does hit the x-axis. So if you want to break it up, you can. You don't really have to, but just in case you want to know. Negative, we're negative from where to where? 2 to 3. Good? Last one. Relative max and relative min. Relative max and relative min. What does it mean to be a relative maximum? It appears to be the highest what? The highest point. What does it mean to be a relative minimum? The lowest. So when I'm looking, what appears to be the highest point? 0.4. What appears to be the lowest point? Negative. What's this one? It's a dip. Okay? Remember, it's a dip. This is a dip. This is a dip. Okay? Even though this looks like the one, this is a min. It has to have the change. Do you remember that? It has to start, and it has to have the change. Then there's the change as well. Okay? So it can't be this one, and it can't be this one, but this is your one, and this is your other. So your relative max was 0.4, and your relative min was -3.0, which was a little confusing, but it's okay. So if I want to write this in terms of f of x, what's our x that goes inside the parentheses? F of 0 equals how much? Good. And over here, f of negative 3 equals what? Good. Don't forget, relative min and max were here. It's any low point on the graph where it changes direction. So keyword is what? Changes direction. Okay? So if you forget that, don't worry. Just make sure you make a note of it. It has to change direction. Same with here, relative minimum. This is on 816. We did same thing. It has to change what? Changes direction. Okay? That is why it doesn't look like the lowest point is the other one. But it has to change direction. Remember, so I said it was coming and then it changed? It dipped it? That's why. Has to change direction. Okay? So if you want to make yourself a note again so you don't forget that, that's fine. I'm going to go back to the table of contents. Yeah.
Is it always necessary to have x equals 1?
Yeah. I'm going to go back to the table of contents because we're going to start our next section. Even and odd functions. Even and odd functions. What are the key features of even and odd functions? What are the key features of even and odd functions? All right, let's identify even functions first. For even, you are going to reflect about the y-axis. You're going to reflect about the y-axis. What do you think makes it even? Why do you think it's called even and odd? What makes it even? Is it an even or an odd function? Why? Because of the exponent. So what makes it an odd function? When it's like a third. Okay? Do you understand? It's your exponent that's making it even and odd. So when we're even, we have an even exponent, yeah? So we reflect around the y-axis. So x comma y then reflects to be negative x comma y. This will make sense when I graph it in a second. So in other words, your x-coordinate changes signs. You also must, this is kind of important, have the point in the middle of the graph on the y-axis. You must have the point in the middle of the graph on the y-axis. On the side, I wrote f of x equals x squared. True? What does that function look like? What does f of x equals x squared look like? You spent a whole semester in IM2. What does f of x equals x squared look like? What does f of x equals x squared look like? What's the shape it makes? One would be no squared. It was all first semester, guys, of IM2. It was what you would all consider to be like the worst part of the year. What did you graph over and over and over again? Parabolas, which is your quadratics, right? What does a parabola look like? What shape does it look like? It's a U, yes. It's a U shape. Narrow determines if you're A. So if we draw this parabola, and we start with our vertex on 0, 0, the basic parabola starts at 1, 1. And remember, this is your axis of what? Axis of symmetry, right? So your axis of symmetry then does what to it? Reflects it, yeah? Flips it to the other side. So then you have your point here, right? Didn't we learn this last year? Okay, so this is your even function, like so. So your even function has 1, 1, which reflects to negative 1, 1. Yeah? Does that make sense? So that's what this part here where it says x, y is then negative x, y. Your x, y was 1, 1. It reflects, which is now negative 1, 1. Okay? So this here, oops, is your even function. Also, I said this had to be where? On the y, what? Must be on the y-axis, okay? Has to be on the y-axis. So, in other words, do we have an H in there or no? Nope, you have no horizontal shift. Okay, if I graph this, is this even? Is it even? No, why? It's not on the y-axis. We're going to go ahead and we'll call it neither because you know it's not going to be odd. Because it's not even. Not on the y-axis. Yes, it has an axis of symmetry. Yes, it does reflect. But it doesn't follow the rule of just changing the x value to be a negative. Okay? That's why it doesn't work. It has to be on the y-axis. Because they have to reflect, so your x is just changing its sign. Okay? Yes, it does have reflection, but it's like 3, and over here is like negative 1. That doesn't mean your x value just changed a sign. Okay? So let's talk about odd. This one you reflect about the origin. which is 0, 0. This one reflects about the origin, which is 0, 0. So this one says x comma y, then changes to be negative x, negative y. Your x comma y then changes to be negative x comma negative y. So in other words, both signs change. Both signs change. Just in case you don't understand, x and y both change. The last one said you had to have a point on the y-axis. This one says you must go through the what? What do you think it has to go through? No. What did we say in the very beginning? The origin. So technically, yes, the x-axis, but also the y. So we must go through the origin. So if I have negative 1 comma 3, when it's reflected, what does it become? 1 comma, I heard it. Negative 3. Okay? I have to turn the page. So when you're ready, I'll turn the page. What? Down? Bless you. You good? Okay. My lines are not very straight, but we'll pretend. Graph the point negative 2, comma 2. If I'm going to have an odd function, and I'm going to go through negative 2, comma 2, where else do I need to go through? The origin, and then where else? 2, negative 2. Why is it 2, negative 2? It's got to be opposite what? Opposite signs. So if this was negative, then it has become positive. And then that's positive, that's become negative. Yeah? Do we see it? So it has to go through the origin. Did it go through the origin? Yes, it did. Did the signs change on both of them? Yes, it did. So therefore, we have what kind of function? Odd. Good. Questions? I'm going to do a couple with you off your homework. Yes, you have to finish the other side of the worksheet from yesterday, okay? But I'm going to do a couple here so we get it. We're going to look at number 1. I want you to talk with your partner and decide if you think number 1 is even or odd as soon as you get the paper. So you're going to decide if number 1 is even or odd once you get the paper. Remember the rules for even and odd. Remember, you can have even, odd, or neither. If you find raise your hand if you think it's even. Raise your hand if you think it's odd. Raise your hand if you think it's neither. Why is it even? It is even. Why is it even? Goes through the y. It has to be on the y-axis. Is it on the y-axis? Yes. Do I find a point that Do I find a point that's reflective? Can you find a point? What point is that? 1, 2. So we're going to go ahead and label it. I'm going to pick a color you can see. So 1, 2. So what's its reflection? What does it need to be? -1, 2. So in your homework, you should put label the points on the graph. So in other words, if you're claiming that it's even, we need to label all the points that make it even. Okay? So I need to know the 2 points that are reflecting of each other where the sign changes just on the x. Your y stays the same, and it must be on the y-axis. Did it meet all those things? Then we're good. Go to 2. I want you and your partner to try to figure out if you can do 2 all the way through. First of all, is it even, odd, or neither? And if it is one of those, find the 2 rules it must be. Ready? What do you think? Even, odd, or neither? Odd. What makes it odd? What's one of the rules? Has to be on the origin. Is it in the origin? Yep, it is at 0, 0. Good. What else? It's reflective, so we need to find the 2 points. So what's 1 point on the other side? -1, 2. So let's see, -1, 2. So we're hoping our other point is now what? 1, -2. Is it 1, -2? Yes, it is. We okay? Understood? Signs change. This was negative. That becomes positive. That was positive. That becomes negative. So that's one of the rules, and the other rule is 0, 0. So we have even. We have odd. Now let's do this one. Still find 2 points, whether you think it's even, odd, or neither. Even, odd, or neither? Do you agree with her? Why? First of all, does it go through the origin? No, so it's not going to be odd, right? So I'm going to put E, I'm going to put O, and I'm going to put N. It doesn't go through the origin, so it's not odd. True? Okay, even has to be on the y-axis. Is it technically on the y-axis? It is, so technically it's on the y-axis. Okay, that point is 0, 2, yes? Then I need to find 2 points on the graph. So let's find 2 more points on the graph. What point do you want to look at? What about this point here? What's this point? -2, 0. And we're looking for the one that would reflect it. We're looking for even. So remember that just changes which value? The x. So we're looking to see if we find 2, 0 up here. Is 2, 0 on it? No. So it's not going to be even because I find the point up here. And that point is what? 2, 4. So then you're going to tell me it's what? It's neither. Okay? Did you see my thought process? I went through and I said, is it on the origin? Automatic no, so I know it's not what? It's not odd. Okay? Next is it on the y-axis? Yes, it is. Now can I find a point that reflects just the x value? No, I can't. So that's why it's neither. We good? Okay, your job is to finish this worksheet and your worksheet from yesterday. Now listen, you guys still have like 20 minutes, so you have plenty of time. If you do not do these last 3 here, I do not give you credit on your whole worksheet. Fair? Because this you have to draw your own and describe why it's that. You have to do one odd, one even, one neither. Can you just copy exactly one of these? No. But are they similar? Yes. Make sense? Okay. So if you need help, you can ask for help. But you have the rest of the period to work on those things. This and the one from yesterday. Good?